So welcome to the second half of the first lesson. In the first half, we really looked at powers. We looked at what the base is, what the exponent is, how to evaluate powers. Now we're going to work backwards in a sense, and we're going to work with radicals. So radical is an expression that's written with a root, also known as a radical sign. So an example would be something like this. This is a radical because we have the root sign and something underneath. Now you should be familiar with this sign, so you should be familiar with what we call the square root sign. But what we're going to move on to is things that look like this. So instead of just having a number underneath the root or the radical sign, there's also an index that's associated here. We might see something that looks like this, and we need to know what all of these mean. So far, you should be familiar with this. This is called the square root. We're going to move on to things like the cube root and the fourth root, so on and so forth. So radicals can be rational. So if I take a look at square root 4, we know that equals a nice number 2. That's a rational radical because when I solve for it, it gives me a nice whole number. Or it can be irrational if I have something like root 3. Again, if I plug that into my calculator, so here's my calculator, root 3 is 1.7320, so on and so forth. So we see that this is irrational because it gives me a long decimal. Okay, so a radical is just an expression with this sign. We're going to go through what all of these mean in just a sec. So common radicals. These are radicals you should already know. This is called the square root. And essentially, if we were in class, I would have made you do these in random order. So let's do that now. Write root 16. You should have wrote 4. Root 84. Oh, sorry, 64. 8. Root 36. Root 1. Root 100. Root 4. Root 81. Root 49. Root 144. Root 9. And root 121. So you should have noticed the speed at which we were answering. Oh, I missed root 25. So you should have noticed the speed at which we were answering these questions. That's the speed I expect for these common radicals. So you should know these square roots up until 144, which is the square root of 12. That doesn't mean we won't go higher, but these ones you should know off the top of your head. The other ones, as you do more practice problems, you'll become more accustomed to some other ones as well. For example, root 225 is 15. So you'll see that in the problems, and as you do it more and more, you'll remember that fact. So this is just one type of radical. We call this the square root. So an example of a square root would be something like root 4. Something to keep in mind is this is the same thing as this, and that's why it becomes important. So let me write that to emphasize that. If I have a square root of 4, that's the same thing as writing this with an index of 2, or a little 2 above the radical sign. This means take the square root. In other words, the answer to this question will be a number where if I square it, I will get 4. So we know that the square root of 4 is 2. So what this is telling me is 2 to the power of the index, 2 will get me 4. Similarly, if I have, so that's an example. I'm going to write another example here. If I have the square root of 9, that's the same thing as saying root 9 with an index of 2. And again, I know the square root of 9 is just 3, and I know it's true because 3 to the power of this index 2 will get me 9. So what is the square root then? The square root is essentially a number. So a number when squared. So the square root is a number when squared will get me will equal the original answer or the original number. So The square root is a number when squared will equal the original number. Here, when I have square root of 4, the original number is 4. So when I take 2, which is the square root, and square it, 2 to the power of 2, I get my original number. Similarly here, the square root of 9, 9 is my original number. If I take the square root 3 and square it, so 3 to the power of 2, it will get me back to my original number. The other roots work in the same way, except for the index changes, and so the exponent changes as well. So an example of something with the cubed root would be root 8, and you have a little 3 above the radical sign. So let's take a look at that. 3. The answer to this essentially is a number where if I take that number and put it to the power of 3, I get 8. So what to the power of 3 gets me 8? Well, that's just 2. So 2 to the power of 3 will get me 8. Much like here when we had the square root, I looked at 2 to the power of this index, so 2 to the 2 will get me 4. Here, because the index is 3, I'm just asking myself, what number to the power of 3 will get me 8? So what is then the cube root? It's a number when cubed will equal the original number. Okay, again, what I'm referring to as the original number is the number underneath the radical. Let me define that here. Original number equals number underneath radical. So let's do another example then. So example, let's say I had 27, and this is a cube root because there is a 3 there as its index. Okay, so what I'm looking for is a number. When I put it to the exponent of 3, I get 27. And the answer there is just 3. So 3 to the power of 3 is 3 times 3, which is 9, times 3, which is 27. That gets me my original number. So you can imagine then the fourth root would be a number, and above the square root, the index is 4. And the fifth root would be a number underneath the radical, and the index is 5 above the square or the root sign. Okay, so essentially all we've changed then from what we used to know about radicals to what we know now is we associate an index with them. When there is no index present, that means it's a 2, so we're finding the square root. If it's a 3, we're finding the cube root. So what number can I cube to get to the original number? If the index is a 4, we're finding the fourth root. So what number can I put to the power of 4 to get to the original number? Or when it's the fifth root, again, what number can I put to the power of 5 to get the original number? I've stopped with just fifth root here, but technically you can go to any number of roots. You can have the 8th root or the 16th root, so on and so forth. So with the fourth root, so let's try this example. We have 16 and 4. So we're looking for an answer where if I put that answer to the power of the index to the power of 4, it gets me 16. So you can think about it. Let's start with 1. 1 times 1 times 1 times 1. 1 to the power of 4 is not 16. Let's start with 2. 2 times 2 times 2 times 2, or 2 to the power of 4, does give me 16. So 2 is the answer. Okay, so what is the fourth root then? It's essentially a number when raised to the power of 4 will equal the original number. And the fifth root works in the exact same way. So if I have the fifth root, so 5 as my index, I'm looking for a number so that when I put that number to the power of 5, it gives me 32. Again, the answer is 2, because 2 to the power of 5 is 2 times 2, which is 4, times 2, 8, times 2, 16, times 2, 32. So the fifth root, a number when raised to the power of 5 will equal the original number. Okay, so hopefully you understand how these radicals work. So just a quick summary, and I'm going to write that up here, is let's say I have 64 and I have the number 3 here. Essentially what I'm looking for is an answer that when I raise that answer to the power of the index, it will give me the original number underneath the radical sign. That's what we're doing always. If you have something like square root 9, again, if there's no number physically written there, you assume it's a 2, and you're looking for a number. When I raise that number to the power of 2, it gives me the original number, which is 3 here. And again, if I'm looking for a number where if I put it to the power of 3, it gives me 64, that is just 4. Now, I'm hoping you understand the concept where you're like, how am I supposed to come up with these numbers? Like, how did Mr. T know the fifth root of 32 is just 5? So to help you with that, I made a little chart for you, and you're going to copy down this chart before we move on to the questions. So this is what the chart looks like. Again, pause the video right now, copy down this chart, and we're going to go through this chart so that you have it as a reference when answering these questions. Along the top, I have different numbers, so 1, 2, 3, all the way to 10. And here I have n to the power of a number. These are your n values. So we're going to work through this. N to the power of 1. So 1 to the power of 1 is just 1. 2 to the power of 1, 2. 3 to the power of 1, 3. 4 to the power of 1, 4. 5, 6, 7, 8, 9, 10. So we know any of these numbers to the power of 1 will equal those numbers. Now we'll go to the power of 2. So 1, which is my n, to the power of 2 is still 1. 1 times 1. 2 to the power of 2 is 2 times 2, which is 4. 3 to the power of 2 is 9. 4 to the power of 2, 16. 5 to the power of 2, 25. 6 to the 2, 36. 7 to the 2, 49. 8 to the 2, 64. 9 to the 2, 81. And 10 to the 2, 100. Now we're going to look at to the power of 3. So 1 to the power of 3 is just 1. 2 to the power of 3 is 8. 3 to the power of 3, 27. 4 to the power of 3, 64. 5 to the power of 3, 125. 6 to the power of 3, 216. 7 to the power of 3, 343. 8 to the power of 3, 512. 9 to the power of 3, 729, and 10 to the power of 3, 1000. For most numbers, 1 to 10, I need you to know up until them to the number to the power of 3. For some other numbers, you will need to know some of these other values as well. So 1 to the power of 4 is just 1. 2 to the power of 4, 16. 3 to the power of 4 would be 81. And 4 to the power of 4 would be, so 4, 6, 1, 256. I don't need you to know the rest of these. Those are larger numbers. That doesn't mean you won't see them. You won't see them as much. Actually, I am going to give you 5 to the 4 because that one's common, but the rest you won't see as much. So 5 to the 4 is 625. Then we have to the power of 5. So 1 to the power of 5 is just 1. 2 to the 5 is 32. 3 to the 5, yeah, that one might show up, 253. Don't worry about 4 to the power of 5. And then to the power of 6, 1 to the power of 6, 2 to the 6 is 64. And that's all you need to know for to the power of 6. Why did I give you this chart? Because this chart will help you solve the questions working backwards. Because essentially what this is giving you is this is giving you the numbers that you can potentially see underneath the radical. Then you will look at the index on top of the radical sign, and that will tell you how to proceed from there. So let's take a look at some examples. So I can't show you examples without covering part of it, but that's okay. So let's take a look at this example. Let's start with something easy, where I have, for example, the square root of 9. Remember, when I have the square root of 9, it just means my index is 9. So let's take a look. I look at my chart, I try to find this original number, 9 is here. This index tells me that the exponent should be 2, which is what I see here. So I'm solving for the n. The n in this case is 3. Because if I take 3 and put it to the power of 2, I get 9. So 3 is the square root of 9. Let's take a look at another example. So let's do 81 and 4. So in this case, my original number is 81. I'm doing the fourth root, which means I'm trying to find a number. When I put it to the power of 4, it gives me 81. So again, try to find 81 on your chart. So I see 81 here, but I also see 81 here. Because you're trying to find the fourth root, you know your exponent has to be 4. So this is what we're looking at. We're looking at 81 with the fourth root, and that intersects with 3. So the answer here is 3. Again, why? Because if I take 3 and put it to the power of 4, that gives me 81, which is what this chart was telling me. 3 to the power of 4 will be 81. I'm just working backwards now. Let's try another example. So example 343, 3. So I'm trying to find the cube root because the index is 3 of 343. Again, look for 343 on your chart. I see it right here. This 3 index tells me my exponent should be 3, which it is. So I know my n value is 7. So this is 7 because 7 to the power of 3, which is what this shows, 7 to the power of 3, will give me 343. So I've created this chart for you to help solve these radical problems because obviously these numbers aren't familiar to you. But I don't want you to rely on this chart over and over again. What you need to do is you need to use this chart to first become familiar with these numbers, but eventually you need to become super familiar so that you start to kind of just know this off the top of your head. So if I give you the cube root of 64, you should automatically know that it's 4. Again, that's not going to happen unless you practice these types of problems over and over again. So let me just do one more example and then we're good. So example, let's do 125 and the cube root of 125. Again, find 125 in the chart. It's right here. The cube root means the exponent should be 3, which is perfect. And so my answer is just 5. So 5 to the power of 3 will get me 125. So hopefully you're more comfortable with these radicals now. I'm going to go through the practice questions, the practice problems on that initial page. Again, use the chart to help you solve these. So I'm going to have this chart maybe overlapping so that we can kind of use it when we need to. So here we have root 36. Remember, when there's no number there, the index is actually just 2. So I can go to my chart and I can look for 36, which is here. The index was 2, which is what the exponent is. That's fine. So my answer is 6. Again, that one you shouldn't have used the chart because you should know the square root of 36 is 6. But I just want to re-emphasize how we're using this chart. Similarly, we have root 9, which we've done multiple times now. I'm just going to give you that as 3. Let's look at this. We have 64, but because the index is 3, we have the cube root. So we're looking for a number where when we take that number and put it to the power of 3, it gives us 64. So let's look at our chart. I see a 64 here. We wanted the cube root, so the exponent is 3. That's perfect. My number has to be 4. So my cube root here is 4. Let's take a look here. We have 27 and the cube root again. So we look for 27, which I see here. Cube root means the exponent should be 3. So the number I'm looking for is 3. 3 is the cube root of 27. Next, we have 16, but we're looking for the fourth root of 16. So look for 16. Again, I see them in two locations. I see it here and here. But because I wanted the fourth root, my exponent should be 4, which is only true in this case. In this case, the exponent is 2. So I'm going to use this. The exponent is 4, so my number must be 2. So 2 is my answer because 2 to the power of 4 is 16. And lastly, we have the fourth root of 81. Again, I look for 81. It's an example we've already done. With 81, again, the fourth root means the exponent is 4. That's great. So my number is 3. Again, this means 3 to the power of 4 is 81. Again, we heavily relied on this chart to answer these questions. Eventually, you need to become fluent in these so that you're no longer using these charts. Okay? So then we get to these harder problems. Again, they're harder because there's more to do, but you have all the necessary tools in order to do these problems. So we have this entire thing. We're like, let's follow BEDMAS. BEDMAS has brackets first. So let's look at what it can do within my brackets. Now, something to keep in mind with BEDMAS, we had B, E, D, M, A, S. We had brackets first, then exponents, division, multiplication together, addition, subtraction together. Radicals fall under the same category as exponents. And we'll see why in a later lesson, but as right now, you should know that radicals kind of have the same importance as exponents when it comes to BEDMAS. So within this bracket, I have a whole bunch of radicals, addition and subtraction. Again, radicals are equivalent to exponents. Again, we'll show you how later. So those need to be done first before the addition and subtraction. So the square root, again, I know it's a square root because there's no number there, so there's secretly a 2. The square root of 100 is just 10. The square root of 4 is 2. And the square root of 16 is 4. Notice how I copied the plus and minus because we were just dealing with the exponents for now. And there's another exponent here. I'm going to keep it as is. So now we have brackets and exponents. Again, the brackets need to be done first. So let me solve this bracket first. 10 plus 2 is 12, minus 4 is 8, and 8 to the power of 2 is what I'm left with. So my final answer will be 64. This looks super complicated. Again, let's break it down. Let's look at what we have. Do we have brackets here? Yes, but there's nothing to do within those brackets, so that's fine. Do we have exponents? Yes, we have pure exponents. We also have these radicals, which we need to work out as exponents as well. So let's do that first. Here we have an 8 being multiplied by this entire thing. So let's copy down the 8. We're not going to touch it, but we can find the square root of 49 and 64. The square root of 49 is 7 over the square root of 64, which is 8. So if you do have a square root like this, so if you have, I'm just going to write it off to the side here, square root 49 over 64, that's the same thing as saying the square root of 49 over the square root of 64. So we can solve them individually. Again, there was no index that was kind of mentioned here, so we're just going to include 2, but that's the index that's there if nothing's written down. So we've solved this. Here we have 125, but we have the cube root because the index is 3. Again, that means the exponent must be 3. So whatever answer we get, we have to put it to an exponent of 3, and it should equal 125. Go look at your chart. You should be able to figure out that the cube root of 125 is 5. So again, just to review, I have my 125 because it was a cube root. I know that the exponent should be 3, and so the answer is 5 because 5 to the power of 3 will get me 125. So I replace that with 5. I'm going to copy this minus here because it's there. And here I have minus 2, that's the base, to the power of 3. So again, if you need to write it on the side, do so. Minus 2 to the power of 3 is just minus 2 times minus 2 times minus 2. And that's going to equal 2 times 2 times 2 is 8. Negative times negative is positive times negative, negative. So this entire thing equals negative 8. Now I can simplify further. So I have a multiplication here and some addition, subtraction. So let's do the multiplication first. Here I have a multiplication of fractions. So I see if I can reduce. I can't reduce this way. I can't reduce this way. I can reduce this way. I can divide both 8 and 8 by 8. So 8 divided by 8 is 1, and 8 divided by 8 is 1. And there's nothing else I can simplify here. So if I multiply this out, I have 1 times 7, which is 7, over 1 times 1, which is 1, plus 5, and the minus in minus 8 will give me plus 8. 7 divided by 1 is just 7, so 7 plus 5 plus 8 will ultimately give me 20. Okay? So this last one, I want you to try on your own, and then pause the video, try it on your own, and then play the video, and I'll explain how to do it. Okay, so taking a look at this, do we have brackets? Yes, but there's nothing to do in here, nothing to do in here. Next, we have radicals and exponents. So there's exponent here, and a radical here, but there's something to do underneath the radical. We need to do that first. So let's copy the -2. Underneath this radical, we have 78 plus 3, which is 81, plus 1 over -4 to the 1, plus -1 to the 5. Something to keep in mind, this means -2 times this whole thing. The 2 is not the index. You would have noticed that the index appears as much smaller numbers attached to the radical sign. So this means -2 times this entire thing. So now that we have some exponents and radicals left, let's solve them. So -2, I'm going to copy. What's the square root of 81? Well, that's just 9. Plus, here I have 1 over -4 to the power of 1 is just -4. Plus -1 to the power of 5. Again, you might need to do this on the side. -1 to the 5 is -1 times -1 times -1 times -1 times -1. And that should just give you -1. So plus -1. I can simplify this. I have -2 times 8 is -18. I have a plus and a minus, so -1 over 4. And here I have -1. I can keep going. I can collect this term and this term. So I'm left with -19 minus 1 over 4. Now I'm left with an addition of fractions, which is really annoying. But I'm left with an addition of fractions. So what I'm going to do is I need to find a common denominator. Here, I know the denominator is 1. So I'm going to make the denominator, the common denominator of 1 and 4 is just 4. So I'm going to multiply the top and the bottom by 4. So here I have -63, which is -76 over 4 minus 1 over 4, which is going to equal -77 over 4. And that's your final answer. Okay, so I hope this made more sense. I hope you understand what a radical is and the different roots to that radical. Again, use the chart for now, but you need to become familiar with some of those numbers. So the homework then is you're going to do handout B, and then you're going to submit your answers on our Google Classroom. Thank you.